Hi, everybody. Um, so this video is section 7.3, trig functions and real numbers. I have a couple things before I get started. First of all, you'll notice I got a bigger whiteboard. Yay. I have another math shirt on today. Mistakes are proof that you are trying. And then I just wanted to add, as I posted the assignment online, the 7.3 practice assignment online, when you're working through that online assignment, I recommend that you write the problem on a piece of paper, do the work on that same piece of paper, like you would if it was a written assignment out of the book. So treat it the same, especially for these problems here. You're going to need to be organized. You're going to need to have a drawing of a triangle and so on. It's super important that all of that, but also because if you're getting stuck and you're having you're missing you're getting incorrect, I can't help you troubleshoot that and figure out what you're doing wrong without seeing your work. So if you have a piece of paper with all of your work on it, nice and neat and organized by question, and you're missing number 12 and you've tried it 3 times and you keep missing the same question, then you can email me with a picture of your work and we can troubleshoot together what you're doing wrong. So please do that. I think that's it for pre-information stuff. So let's go ahead and get started. So you're going to be given an angle. It may be in radians, it may be in degrees. That's the other thing I wanted to add. If you have not watched and done the homework for sections 7.1 and 7.2, you're going to want to do those before you do this one. There's a lot of, hey, recall we talked about this, that I'm going to do today. I'm going to remind you of stuff we've already talked about. So if you haven't watched those videos and tried those kinds of problems, then you will have a tougher time making sense of what I'm going to talk about today. So let's start by recalling the angles so that we can, and how to convert maybe degrees to radians. So the first one we talked about was pi over 6 is the same as 30 degrees. Pi over 4 is the same as 45 degrees. Pi over 3 is the same as 60 degrees. Pi over 2 is the same as 90 degrees. If you have those 4 in front of you or memorized, whichever, that will be super helpful today. You won't have to actually convert. So remember, if I was going to convert 4 pi over 3 to radians, I'm sorry, 2 degrees, you would take the 4 pi over 3 and you would multiply by 180 over pi. And then your pi's cancel. And then you do the math. 4 times 180 divide by 3. And either way, you get 240 degrees. Okay. The shortcut we talked about in this lesson, and I don't remember if it was 7.1 or 7.2, was just that pi over 3 is the same as 60 degrees. So this is the same as 4 times 60, or 240. So you can continue converting using the long way, like I showed you here, and what I covered in that lesson. But again, it's a long way. It's longer, right? So it's going to take you longer every time, and this is going to get easier the more you do it. So the key is either to have those in front of you while you're working at the top of your paper on a little note card that you can look at, or memorize them. Eventually, if you use them enough, you'll memorize them. Okay, so the next step, the other thing we're going to need to recall for this lesson are our 2 special right triangles. So the 45, 45, 90 right triangle is the one that has a 1, and a square root of 2. And then the 30, 60, 90 has a 1, a hypotenuse of 2, and a square root of 3. And it's really important as you use this triangle specifically, that you orient it correctly. So make sure that the 60 and the side one is adjacent to the 60 angle, and the side square root of 3 is adjacent to the 30-degree angle. I keep it in mind by thinking about the threes being together. Okay. And so again, that is just something you might want to have at the top of your paper, or again on a note card for you to use. So step one of this process is to draw the angle and what's called a reference triangle. So 240 degrees is between 180 and 270. So it might fall somewhere like that, right? Keep in mind that this is the positive x, y. This is x, this is y, positive, positive, negative, negative, right? Keep in mind that that's what we're drawing this on. It's easy to lose that. Okay, so what I'm going to do is draw a reference triangle straight to the nearest x-axis, and it's going to be a right triangle on purpose. Okay, so we want a right triangle so that we can use our sine and cosine tangent. It has to be right. Okay, so that's this first step, is to draw your reference triangle. Find your reference angle. So remember our work with reference angles. They're always between the angle and the nearest x-axis, right here at the origin, right there. So your job is to figure out how big that angle is. So if this is 180 right here, and this is 240 down here, 240 minus 80 would leave me with a 60-degree reference angle. Now you might notice that 60 is what we used up here to calculate our degree angle measurement. It is not a coincidence that this angle and that angle are the same. That will always happen. Your reference angle will always match the angle that you used up here to calculate if you used this shortcut, which is not a good reason to use the shortcut, because then you'll kind of have that affirmation that you found it correctly. So those should match. The other thing is all of your reference angles in your assignment will be one of these. It's going to be a 30, a 60, a 45, a 90. It's going to be every time. Okay, so the third step then is to label your reference triangle. So if this angle, this is where our two special right triangles come in. If this angle is 60 degrees right here, adjacent to the 60 is a 1. Across, opposite of the 60 is our square root of 3. And the hypotenuse is a 2. And then you want to make sure to include any negative So what I want you to think about is, again, going back to the fact that this is the x-axis, this is the y-axis, to the right is positive, to the left is negative, up is positive, down is negative. To get to this point right here, I would have to go to the left and down, which means that this 1, I went to the left and that's a negative 1. I went down and that's a negative square root of 3. Yeah? So does a triangle exist with 2 negative side lengths? No, not for real. I mean, there's no actual way to make a triangle with negative side lengths. This is a visual representation to help you find the 6 trig functions for this angle that lands right there. So keep that in mind. It's not an actual thing you can touch. It's a visual representation. Okay, so our sine of 4 pi over 3, using our angle right here, opposite over hypotenuse, a negative square root of 3 over 2. So when I do my reciprocal, which is cosecant, I just want to reciprocate that, right? So now it's going to be 2 over the square root of 3, And then I have to rationalize that. So I end up with 2 square roots of 3 over 3, negative. So negative 2 square roots of 3 over 3. Let me erase this. So then our cosine of 4 pi over 3 is adjacent, so negative 1 over 2, and our secant, which is the reciprocal, it would be negative 2. So negative 2 over 1, right, or negative 2, and then the tangent, opposite over adjacent, so negative square root of 3 over negative 1. Let me erase this, sorry. Which is just the square root of 3. And then the cotangent, so we would have negative 1 over a negative square root of 3, right? And then we want to, the negatives cancel just like they did here. And then we want to rationalize, so we end up with a square root of 3 over 3 for the cotangent. Mm-hmm. Okay, so I erased my 3 steps over there, but I'll just recall them. So the first one is to draw the triangle, or to draw the angle and its reference triangle, to find your reference angle, and then label your reference triangle, including any negatives. So we'll go through that process with 2 more examples. And I'm going to leave that stuff over there for reference as we work. Okay, erasing. Okay, so the first thing we do is to draw the triangle is convert this to degrees. It's way easier to draw a triangle when you think of it, because we think in degrees, we don't think in terms of radians. So pi over 4, according to over there, pi over 4 is the same as 45 degrees. So 3 times 45 degrees is 135. So let's draw like this. 135 would end up right there. You might even think 3 45-degree angles, 1, 2, 3, and that tells me that this triangle, which I'm going to draw right here, has a 45-degree reference triangle. That's what's left, right? 1, 2 45-degree angles, 3 45-degree angles, 4 to make one full. So using my 45, 45, I know the 2 legs are a 1 and a 1, and the hypotenuse is a square root of 2. And then keeping in mind that I have to add negatives for anything that would be negative on the XY axis. So we're going to the left and up, which means this is a negative 1. That is a positive 1, right? To the left means negative for X, but up means positive for Y. So the sine of 3 pi over 4 is 1 over the square root of 2, which again, we will rationalize that denominator, making it the square root of 2 over 2. And if I'm doing the reciprocal, I don't have to rationalize the denominator because it would just be a square root of 2 over 1, right? If I reciprocated 1 over the square root of 2, it becomes square root of 2 over 1, right? Erasing that right there. The cosine is adjacent over hypotenuse. So that's a negative 1 over the square root of 2. And rationalized, it would look like square root of 2 over 2, just like what I showed a second ago for the sine. And then the secant, which is the reciprocal, would be just a negative square root of 2. The tangent is opposite over adjacent, so 1 over negative 1. And the cotangent, also negative 1. Okay, so for the next 3 examples, I'm going to go through the process of drawing the angle, drawing the triangle, labeling the triangle. But this here, labeling, filling out all of the triangle, the trig functions. I'm just going to skip that part. So I think you all have the basic idea of how that works, and that's a pretty long process. So. And also be careful on your assignment because it won't ask for all of them. It'll ask for specific, like just the sine and the cosine or just the tangent or whatever. Okay, so what if we were asked about 11 pi over 6? Erase this. And I'm going to go ahead and erase these as well. So we can get 3 different triangles up here all at the same time. So 11 pi over 6 is 11 times pi over 6. I just erased it. Is the same as 30 degrees. So 330. So if I draw a picture of that, 330 degrees is going to land kind of right here. Again, you don't have to be super accurate with where it lands. You just have to make sure it's in the right quadrant with enough room for you to draw your little triangle. Okay, so this is 330. And if you do 360, we're going to drop our reference triangle here, right? 360 is the x-axis if we went all the way around, right? So 360 minus 330 is 30, and there's that not coincidental reference angle we talked about. And so then our special right triangles next are adjacent. The 30-degree angle is the square root of 3. Opposite, the 30-degree angle is a 1, and then the hypotenuse is a 2. And then this 1, would it be a negative 1? Because to the right on the x-axis is positive, but down on the y is negative. And the hypotenuse is never negative. Okay. All right, so what if they give you negative 210 degrees? You don't have to convert anything, but you do have to draw an angle in the backward direction, right? Oh, this isn't going to work, sorry. Let me redraw that. So if I go backwards 210 degrees, I'm going to land right here. Right? And if this is 180 and that's 210, then when I draw my little reference triangle, the reference angle right there would be 180, or would be 30, sorry. So then my square root of 3 is here, my 1 is there, my 2 is the hypotenuse. And again, labeling any negatives, the square root of 3 would be a negative to the left square root of 3. So that one's negative. And then my last example in this of these kinds of questions is also in degrees already for us. It's just an example of bigger than 360. So 675 is the same as 360 plus 315. So when you think of that angle, that means the 360 means we went 1 full revolution around, and then we continued 350 degrees, 15, degrees further. So it looks something like that. And so our triangle would land here. If this is 360 and we went 315, then our reference angle is 45. And that's a 1, and a square root of 2. And then we want to be sure and label this one as a -1. All right, so basic steps, reiterated multiple times for you. I hope that if you have any questions, let me know. Okay, so I want to show you what I call butterfly wings. One of the biggest mistakes students make is they draw the reference triangle to the wrong axis. You want to make sure that your reference triangle is always drawn to the nearest x-axis. So if I have an angle in any one of the 4 quadrants, the triangle should always go like that. And so this is what I refer to as butterfly wings. That you should never, ever, ever put your triangle here, okay? You should never go to the y-axis with your triangle. You should always make the triangles like so, to the nearest x-axis. And then, of course, your reference angle would always be in here. So think of that as kind of like the decoration. And then you can think in terms of positives and negatives, right? So to the right and up is positive, and the hypotenuse is always positive. Up is positive, hypotenuse is positive, but to the left is negative for this triangle. To the left is negative, down is negative. Hypotenuse is always positive. To the right, but down, hypotenuse is always positive. So that's just kind of a little diagram that might be helpful. Okay, so what happens if the angle lands on one of the x or y axes? So that's the last thing I have for you. I'm going to go ahead and erase. I'm going to erase my butterfly wings. And then what happens if it lands on the x or y axis? So 3 pi over 2. Pi over 2 is the same as 90 degrees. So this is negative 270 degrees. So this is what we're talking about. What happens when that's bigger than I want? I need to do all the, we're gonna fill out all the 6 trig functions on these. So we can talk about some of that as well. Okay, so negative 270 means it goes like that, right? 3 90-degree angles. So where do you draw your triangle? Well, it has to be, we talked about the butterfly wings, it has to be here or here. I'm going to draw it to the right since the left side has that little bit of a thing in it. So there's my imaginary triangle that doesn't really exist, but it's a visual representation of what I'm going to do, right? Okay, so how do you label the triangle? Well, you don't have a special right triangle for labeling. What you do instead is you pick a point on the axis that it lands on. So if it landed on the y-axis up here, my ordered pair would be 0 for x and something for y. I could use anything for y, anything. The easiest thing would be to use a 1, right? So that means we went to the right 0, but up 1. And then if you did your a squared plus b squared equals c squared, Pythagorean, you have 0 squared plus 1 squared So the hypotenuse is also 1. And that is also not a coincidence. Those two numbers should match. So what if instead I had used a 5 right here? I could use a 5. I could use the order pair 0 and 5. Absolutely. So that would be a 5, and this would be a 5, and this would be a 5, and that would be a 5. And so the hypotenuse would also be a 5. So what I want you to think about again is that this is a visual representation of something that if I smashed those two lines together, they would just be the part of the y-axis I'm referring to. So those two should always match, because this length is 0, right? This doesn't actually exist. It's 0. So what we have is these two lines lying right on top of each other. Okay, so then if I'm doing my sine of negative 3 pi over 2, again, I'm using this triangle right here. My angle is right here on the inside like it always is. The sine is opposite over hypotenuse, so 1 over 1. That means the cosecant is also 1. Yeah? The sine, well, I cannot talk today. The cosine, trying not to throw my stuff, is adjacent over, so just 0. That means that my secant, when I flip that fraction over, the 0 is in the denominator of the fraction, which means it's undefined. Please abbreviate U and D, and I think maybe in the book, the online, you might have to type it in undefined, or it might give it to it as an option. So then the tangent, opposite over adjacent would be 1 over 0, so again, undefined. And then the cotangent would be 0 over 1, so 0. So 0 divided by 1 is 0. 1 divided by 0, so 0 divided by 1 is 0. 1 divided by 0, undefined, cannot divide by 0. Okay, I'm going to erase this. And we're going to draw the next one over here. If I'm asked for 540 degrees, again, that's bigger than 360. That is 360 plus 180. So my angle, it goes around one full revolution and then it stops there, right? So again, with the idea of butterfly wings, I could draw my here or here, but it needs to be on the left. It doesn't matter. It could be up or down. And I pick a point on the x-axis right there. So the y value is 0, and the x would be a negative number. So I could use, again, I could use -1, -2, -5. It does not matter. So -1 is the easiest. And then we label our triangle. Since we went to the left 1, that 1 goes there. Up 0, that goes there. And then again, if I did my Pythagorean theorem, a squared plus b squared equals c squared, I would get a 1 right there. Keeping in mind that when we multiply -1 squared, that -1 squared is just 1. It would never be negative, right? So that again is the reason why your hypotenuse would never be negative, because whenever you square a negative number, you end up with a positive number, and then you take the square root and you're still positive. So I'm going to leave these here, and I'm just going to fill in the answers like so. Okay, so the sine of 540 degrees would be, again, we're using this angle right here, right? So opposite over hypotenuse is 0 over 1. That means the cosecant of 540 would be undefined. Again, maybe I should erase so this is not confusing. Okay, that's better. So the cosine of 540 would be adjacent over hypotenuse, so -1, which means the secant of 540 is also -1. The tangent would be opposite over adjacent, which is 0, and the cotangent, the reciprocal of that, would be undefined. Okay, so that is everything I have for you today. Again, be sure to take a look at the online assignment that I have posted and let me know if you have any questions.